Okay, students, here we are moving on to a little bit more complicated equations today. So we're going to be adding another step to our equations, and this is where things start to get a little bit fun. So today we're going to be looking at multi-step equations. And so how this is different than the equations that we've been doing is now we're going to be looking at more than 2 steps. So this might be 3 or 4 or 5 steps in order for us to solve. Now, when we're solving, our goal is still the same. Our goal is still to isolate that variable, to get the variable all by itself. But we have a new step we've added in, and that new step is simplify. So that means when we're looking at our equation, we're going to be looking at each side, and there might be like terms that we need to combine. There might be distributive property that we need to take care of. There might even be fractions that we have to simplify. So we're going to work through these problems slowly. And then, of course, when we get to the end, we're going to do a check just to make sure that we have our work correct. So we'll go through them together and make sure when you're doing the problems that you're showing all the steps exactly like I am. I'm going to be really, really particular about us not skipping steps and us showing the work exactly like this. So here's our first problem that we're talking about today, and we can see that these are a little bit longer than what we've been doing for the past couple of days. So the first thing we want to do is we want to draw that line that divides our equation into 2 parts. And what I'm going to be doing is I'm going to be looking at all the terms that are on the left side of the equal sign. And the first thing I'm looking for is, can I simplify? Are there any terms that are alike that I can combine together? So hopefully you're noticing that 8x and 3x both are variable terms. So we would want to first combine those together. So 8x plus 3x is 11x. Then the next thing we would want to do is see if there are any other like terms that we can combine together. So we can see that we've got a positive 6 and a negative 2. And when we add positive 6 plus negative 2, we get positive 4. Now we're going to go ahead and look at the right side of our equation, and all we have here is a 37. So we're going to bring down that 37 and bring down our equal sign. Now when we get to this point, we can see that, oh, we're just back to a 2-step equation, which is what we were working on the other day. So now we go through our order for 2-step equations. And the first thing we would want to get rid of is that plus 4. The opposite of adding 4 would be subtracting 4. So we would subtract 4 on both sides. Again, make sure you're always showing the operation on both sides of the equal sign. A positive 4 and a negative 4 are opposites. They cancel each other out. We're going to bring down our 11x. 37 minus 4 is 33. Okay, now we can see that we have 11x, which means 11 times x. The opposite of multiplication is division, so we're going to divide both sides by 11. So 11 divided by 11 is 1x, or we just write x, and 33 divided by 11 is 3. Now, when we get to this point, don't be tempted to be done so quickly. We know that the most important thing is that we have to go back and we need to check our work. So when we check our work, we always go back to the original equation and we rewrite the entire original equation. Then what we're going to do is everywhere we see our variable, we're going to plug in what we believe to be the answer. We're just checking to make sure we haven't made an arithmetic mistake somewhere. So this would become 8 times 3 plus 6 plus 3 times 3 minus 2 equals 37. And now we just solve using order of operations. So 8 times 3 is 24, plus 6, 3 times 3 is 9, minus 2 equals 37. So 24 plus 6 is 30. Bring everything else down. 30 plus 9 is 39. And 39 minus 2 is 37. So as soon as we see that both sides are the same, we know, yay, we have the problem correct. So we're ready to move on to the next problem. So again, we always have to check our work. Let's take a look at another one. So same thing, we're going to draw that line down the equal sign. We're going to start by combining like terms. So I can see my variable terms, 9x plus 4x. When I add those together, I get 13x. Then I have positive 5 minus 2. When I add those together, I get positive 3 equals 42. Now we're down to a two-step equation. We always get rid of addition or subtraction first. We see addition. So the opposite of addition is subtraction. We're going to subtract 3 on both sides. A negative 3 and a positive 3 cancel each other out. So all that's left is 13x equals 42 minus 3 is 39. Now we know 13x means 13 times x. The opposite of multiplication is division. So we're going to divide both sides by 13. 13 divided by 13 is 1. So we just have x. 39 divided by 13 is 3. Now again, when we get to the bottom here, we don't quit. We know that the most important step is to go back and check that answer. We want to make sure that we haven't made an arithmetic mistake. So the check is mandatory. We have to do the check. If you're not doing the check on your work, I'm going to send you a little message to redo it. So we rewrite our equation. We plug in everywhere that our variable is the answer that we believe to be the answer, because we're checking to make sure we haven't made an arithmetic mistake. It's really easy to make an arithmetic mistake. It happens to all of us. So we're plugging this in everywhere we see an x. We're changing that to times 3, and we're going to see what happens. So 9 times 3 is 27. Plus 5, 4 times 3 is 12, equals 42. Now I follow order of operations. 27 plus 5 is 32. Bring everything else down. 32 plus 12 is 44. Bring everything else down. 44 minus 2 is 42. Now, as soon as I see both sides are the same, I know, yay, my answer's right, and I can move on to the next problem. Now, this next problem we're going to look at is a little bit tricky. It might look a little scary at first, so do not freak out. I know some of you just kind of had a little bit of a panic attack there because you saw those fractions. Don't worry, we're going to be okay. Now, I'm going to show you how to clear the fraction. So we've got all of these fractions, and what we want to do is we want to think of a common denominator between 9, 2, and 3. And some of you already have it because you've got your multiplication facts down really, really well, and you already know that common denominator. For the rest of us, we can just write out our multiples, 9, 18, 27, for 2, 2, 4, 6, 8, 10, 12, 14, 16. Oh, thank goodness, I finally got one there. 3, 6, 9, 12, 15, 18. Okay, 18 is our magic number. Everything's divisible by 18. So what that means is we're going to multiply every single term in this problem by 18. Now I'm going to do this off to the side one at a time because it's going to be tricky for some of us. So the first thing I'm going to do is 18 over 1 times 7x over 9. This is where it's really important to cross cancel. 18 and 9 are both divisible by 9. See how my denominators became 1? That's what I want because that means the fraction went away. So 7x times 2 is 14x. So my first term becomes 14x. Now I'm going to distribute 18 over 1 times x over 2. So again, I want to cross cancel. These are both divisible by 2. And my second term becomes 9x. I'm going to do that again with the 17 over 9. So 18 over 1 times 17 over 9. I'm cross canceling here. These are both divisible by 9. 17 times 2 is 34. Now be really careful. There's a subtraction. So this is minus 34. Okay? Equals, and then a lot of times people will forget, I also have to multiply 18 over 1 times 2 over 3. Cross cancel, and you get 12. So this is my new equation. 14x plus 9x minus 34 equals 12. Now we can see we're back to combining our like terms. So 14x plus 9x is 23x minus 34 equals 12. We get rid of subtraction by adding 34 to both sides. We have 23x equals 45. We divide by 46. Did you guys see I made an addition mistake there? That's okay, that happens. I caught it though. We divide by 23 and x equals 2. Now, some of you are going, oh my gosh, now I got to check it. So I am going to allow you to not do a check if the original problem has fractions. But it's a little risky. You're taking a risk by not doing your check. But because the fractions are so challenging, that is the one time I'm going to say it's okay not to do a check if the original problem is all fractions. Okay, go ahead and do a bunch of practice and let me know if you need any help.